And as a fun fact, he's a huge Lord of the Rings fan.
Yeah.
So my question here is, which one is your favorite character?
Aragorn.
Aragorn, yeah. That one is easy.
Strider.
Okay. As a reminder for all of you, if you have questions, you can use the Google Doc that is written in your badge to write your questions. I will be providing the questions to Federico at the end of the presentation, and we can, even if you have additional questions, we can discuss them within the given time. So I think we're ready and we're all set. So if you please welcome Federico, we'll start the talk. Thank you.
Thank you. All right, thanks guys for coming. Just before we kick off the session, I'm going to tell you something, a bit of logistics. Two things. Number one, this will be an advanced level talk, so I will assume some familiarity with Kubernetes. Number two, this could go really well or really bad. This will be an interactive talk. So there will be some questions that will appear on the slides. I'm going to need some answers from the audience. The questions are super simple. These are meant for a small crowd here, so like as we are today. But feel free to, when the time comes, to shout them out loud. So if you don't do that, if you don't say anything, it's going to be really awkward. It'll be like silence, and everybody will be staring at me. So, my name is Federico. I work at Contino. Contino is a global DevOps and cloud transformation company. We help large enterprises moving from on-premises to cloud and building architectures in cloud. We often work with cloud-native products, like Kubernetes. And this talk comes from that experience. What is happening in the industry, you all know this. We've had this huge growth in terms of containers adoptions, container utilizations, and Kubernetes, the cluster scheduler de facto, having now entered the supremacy level. All the other competitors that were popular against Kube in 2015, 2016, 2018, they're all disappeared effectively, and Kubernetes is running the land. What is happening in the space, though? What is happening in the space, though, is that we're seeing lots and lots and lots of enterprises entering significant adoptions of Kubernetes. How are they doing that? Well, they're doing it, they're pushing it. Why? For one reason and one reason only. Because everybody says, I want to adopt Kubernetes because it will help me preventing lock-in. I'm getting to Kube because if I have my containers running on premises, I can take them to cloud, any cloud providers, whatever that is, and it will run there. That is the big promise. That is the big promise. The promise is I have a turnkey migration, super easy, straightforward, from one place to the other. This is what all our customers tell us, or most of our customers tell us. I want to work with you in this case. I want to see whether that is true or not. So what are we doing here? What are we doing here all together today? All together today, we are a migration team. We're working in a company. The company is doing a B2C product. They have a mobile applications. We have a backend. And the big task for us is we have to move our containerized workload running on AWS in Kubernetes onto GCP. AWS to GCP migration of a containerized Kubernetes workload. Pretty straightforward with some good news. So what are the good news? Well, number one, our landing zone on GCP exists already. Kubernetes GKE in GCP is up and running. We can stop the world for all of you in Java land, so I can stop AWS and spin up GCP. No traffic shifting, no magic, super straightforward. Just turn it off, turn it back on again. And we have a very modern tech stack. We'll look at the architecture in a minute. We're not going to worry about networking. In other words, this is a simple migration, as simple as it gets. Okay? All right. Okay. One thing to think about, though, very important, we have a range of stakeholders in our game. We have 5 core stakeholders. Not only our mobile developers and our users need to be able to connect to the application once the app is on GCP. But our backend developers need to be able to deploy. Our security team needs to be comfortable with the fact that we haven't changed the security posture of our environments. Our SRE team needs to be able to manage the application. This is the architecture on AWS. Let's look at this together for a few minutes. One mobile application speaking with a microservice number one, HTTP REST, running in running on AWS, on EKS, manage AWS Kubernetes service. We upload an image. The HTTP microservice says, okay, HTTP post, I got it, happy times. Microservice stores the image on S3, saves the metadata on a RDS Postgres database, and then talks with another microservice via queuing system. Second microservice receives the message over the queue, straightforward, nice and easy, sends this to a third microservice that then sends a message back. So, 3 microservices, written in Golang, written in Rust, or written in the most advanced programming language you can think of. These 3 microservices, all running on EKS, are going to go to GKE. The 2 dependencies are S3, database, queuing system, Grafana, and Prometheus for monitoring, and one thing, HashiCorp Vault for secrets management. The architecture on GCP is exactly the same. 3 microservices running within GKE. We're replacing S3 with cloud storage. We are replacing RDS with Cloud SQL and PubSub for SNS. And then we have a couple of things there. So, we are on our migration journey. This company needs our help. And we are the migration team. We have been told, and we believe the hype. We think the hype is real. The hype is, I can turn key migration. I can just do a simple thing. I believe the articles online. We're using GitHub Actions, Argo CD, whatever is the CI/CD tool you're using in your company. And we're doing one thing. We're doing one thing only. We're taking the YAML, changing the endpoint. So GitHub Actions deploys this YAML code to GKE. The YAML code was running on AWS, no problem. We're deploying this YAML code on GKE. As it is, done, nothing else. Will it work? Yes or no? No. All right, agree with you. Why? Yes. I'm not sure who said this, but that's the point. So, the registry. So, we have our applications, our registries on AWS. So, let's run on it. What can we do? Can we pull an image hosted on AWS Elastic Container Registry from a GKE instance? We can do that, but we lose something in the game. I have 3 options. The trend will continue. To simplify portability, option 1, I use a CNCF project or a commercial off-the-shelf solution, Artifactory or Harbor, and I import them in the cluster. If I remove the dependency from the AWS service, I import it in the cluster, and I'm just going to depend on it. So when I move to GKE, my registry will come with me. Option 2, I can keep my images on ECR and deploy on GKE. But if I do that, this is going to be a bit of an advanced point, but if I'm going to do this, I'm going to lose the ability of using self-managed node. I need to add a shim of code into GKE, so I need to run my own nodes on GKE. I pay on maintenance cost. I don't want to do this. Option number 3, I move to GCR, Google Container Registry. The thing is, reality, the API surface of Google Container Registry and AWS Elastic Container Registry is the same, so who cares? Let's just move on to the other. Pull from one place, push to the other, no problem, right? Except our security team says, you're being weird now. Why? Because if you think about it, reality is that in a large enterprise, when you're adopting cloud services, it's not like you're just adopting them. You're trying to follow a set of best practices. What are the most common best practices available in the industry? CIS benchmark. CIS benchmark is the most common set of best practices. The CIS benchmark for AWS says, do it as it is, it was fine. But the CIS benchmark for GKE says, enable a feature of GKE called binary authorization. In other words, require signed images for deployment in the cluster. This is an interesting point. It's not a technical limitation. But think about this. As a migration team, we want to satisfy security requirements, and as such, we want to stay in compliance. To stay in compliance, we will need to use binary authentication, sign the images. The feature doesn't exist on AWS. We will need to build it on GCP. That takes a bit of effort. But nonetheless, we do it. It's easy. We continue our migration journey. We move on to the next topic. We try again, redeploy again. Will it work now? Yes or no, based on the YAML? No. Why? Same thing with the database. Same thing with database. So I have a database, I have RDS on GCP, on AWS. Can I use RDS? No, I need to use Cloud SQL on GCP. The good news on this case is that this is 2023, not 2016 or 2017. Why? Because in 2016 or 2017, the Cloud SQL and RDS were at very different level of maturity. RDS had way more features than Cloud SQL. Now they caught up. So the services are very similar. The swap is very easy between one and the other. But there's one point I want to bring in to make you think. The point is, the alternative to this, to simplify and increase portability in order not to depend on the cloud provider, would be to bring in inside the cluster Postgres. If I have a database inside the cluster, I can move it very easily. But can I do it? Of course I can. There's a Postgres operator maintained by a company called Zalando. I'm sure most of you will know. It's an open source project with Patroni as well that allows for easy HA deployment of Postgres within Cube. Amazing, everybody's happy. So I could use this service to simplify deployment, bring it in the cluster. But if I do this, I pay a price. This is one of the takeaways of this talk. We're going to give it in the first 10 minutes. This is one of the takeaways of this talk. The trend is, yes, I can bring inside the cluster all these resources to increase my portability, but I have a price to pay if I do that. There's a cost. It is called the maintenance cost. This is the trade-off that we're making here. The trade-off that we're making here, the illusion is that we're making a technological trade-off, choosing between Patroni, the Kubernetes operator, and RDS. Is not. It's a business trade-off. You need to think of the business case, and when making a choice on one versus the other, think about your cost, your velocity. What is more important for the company, being portable or being faster? Because if you want to be faster, use the managed service. If you want to be more portable, think about bringing it in. But there's a cost. There's a clear monetary cost to it. Okay. We're continuing our journey. And we saw our container registry, we saw our database. Finally, is this application up or down? Yes, it's up. All 3 microservices are up and running. Kubernetes is happy, says passing the health check, passing the readiness probes. Everything is fine. We ask one of our users, can you please upload an image? The user tries to upload this image. Try user, there you go. User tries to upload the image. However, doesn't work. HTTP 500, why? Why did the user get a 500 error? Come on, random ideas. What are we missing? Say again? That's a very good point. So managing the ingress or the network, fair enough. We're not worrying about that in this exercise, though. We're kind of like forgetting about it. So we're missing our storage system. Think about it. The user tries to upload something, goes to the machine on GKE. The machine on GKE says, oh, I need to get to S3. I need to upload that image to S3. but I'm on GKE now. Can I upload an image to S3 from a GKE instance? Of course I can. What are my options though? Options-wise, as before, one thing I could bring in inside the cluster either with kubefs or Rook, a CNCF project that will help me reduce dependency because it stays within the cluster. Rather than uploading to S3, I upload to Ceph. Option 2, I can keep the object storage in S3 and I have to transit the network to go from one place to the other. I have to pay egress cost, but I can decide to do it if I want to. Option 3, I can move to Google Cloud Storage, GCS. Google Cloud Storage, which helps me to saving the images there. Google Cloud Storage functions in two ways. Google Cloud Storage has its own API set, and the second API set of Google Cloud Storage is the S3 compatible API set. So I can use the AWS SDK that I have in my application, in my library, in my application, pointing it to GCS so that I don't need to touch the application. These are our three options there, as before. Or, what if something else? An interesting feature in this case, that is one of the features that has gone GA in Kubernetes a year and a half ago, I think 2 years ago, is called Container Storage Interface. How does this feature work? I assume some level of familiarity, but Container Storage Interface is a standard to expose arbitrary block and file storage systems to containerized workloads running on pods as directories. Let's see, so today, our application from one microservice goes to S3 via an HTTP call. If I use Container Storage Interface, the application doesn't go to S3 anymore, but reads from a local directory there. That local directory is mounted as an S3 bucket behind the scenes by Kubernetes using a driver, which means that if I swap S3 for cloud storage, I don't touch the app. I only touch the backend there. So this is called Container Storage Interface, a series of drivers that are available within Kube, and it's a Kube feature. They work, they exist, there is drivers for AWS and GCP, but don't forget, we're dealing with file storage on one hand, we're dealing with block storage on the other side, POSIX dependencies. These drivers are great if you're doing simple things. But for example, you cannot set ownership of files, permissions, you cannot set them. You have this, is a fuse-mounted file system, so yes, you have some limitation. It doesn't support symlinks or hard links when dealing with these directories. And these are very under significant development services. So you can do it. You could potentially leverage Container Storage Interface with Kubernetes, but it's something you can think of to increase portability. The good news is, though, let's just say that we decide that we're going to Google Container Storage, and when we're going to Google Container Storage, we realize that it's super easy because the authentication model across Kubernetes is the same. They're both using service accounts. So I can go to Google Cloud Storage with service account with that level of authentication, really easy. I need to change, though, my source code. If I remove S3 and I put in Google Container Storage, Google Cloud Storage, without anything I need to use, I need to change the SDK. Clearly, I was using the AWS SDK before, and I was using and I'm using now the Google Cloud SDK. It's a bit of an SDK change. It's not a problem for one microservice importing one library or the other, but if you're Netflix, if you have 1,500 microservices, if you're Monzo and you have 1,000 microservices, that starts to be a problem. This is why in the industry there's a standard, sorry, I'm not doing anything there. There's a standard in the industry called anti-corruption layer. So if you have multiple microservices, what do you do, rather than having them all talking to the same dependency, what do? You have them talking to a facade, an anti-corruption layer. The anti-corruption layer talks with S3 or whatever is your dependency, And then when you bring in microservice number 2, application service number 2, well, then you just touch the anti-corruption layer. It's something you have to think about proactively when designing the application. Yes, fair enough. You can deploy it later as a strangler, so you have this in front of S3 and slowly chip away at that. But nonetheless, it's an idea. 500 microservices, think about the facade. Okay, let's continue our migration journey, how we can simplify this. We did 1, 2, and 3. We're number 4. We know that we have our application that depends on a queuing system. So I upload the image, I get to the queue, and I'm like, oh, yeah. Now I'm on GCP. I was on AWS SNS. I'm using PubSub now. Can I just change the queue endpoint of my YAML? Can I just tell the application, hey, don't go to SNS there, go to PubSub? Yes or no? No, probably no. Why? Different protocols, different services, different systems. Right, so can I swap Kafka for RabbitMQ? Can I swap SNS for PubSub? No. Agreed. Obvious. Why? Why can I not? Because here is the problem. We're making a cursory use of this distributed system patterns. We are just sending one message from one place to the other. The pattern has been in the industry for 40 years. We're not doing anything clever. There's no sharding. There's no dead letter queue management. There's no system complex Kafka, KSQL streaming. There's nothing there. Message from one place to the other. Banks in the 80s were using TIBCO there. So like ESBs, right? All of that in place. Why cannot we do it now? Our cursory use, our system, use of a queue is absolutely cursory. We are making super simple things. Still, moving from one cloud provider to the others means changing the app completely, changing the libraries, because these two applications, these two systems have different API services. It's something I think we should think about and asking ourselves why. Let's go practically though. What are our 3 options? Option 1, nets. Bring inside the cluster your queue dependencies. If I use nets or I use Kafka, they stay inside the cluster, and when I move from one cloud provider to the other, they're with me, everybody's happy. Option 2, I could keep the messaging on AWS, and so my application from GK speaks with AWS. I can do that. I would have a bit of a latency impact. There's a discussion there. I don't think it's too much, but I still can do it. Option 3, I move to PubSub. In our case, we say, let's kill AWS. We're moving to PubSub. The immediate implication of doing this is changing the API surface, fine, change the library, change the SDK. This is a problem now, because I'm sure that most of you will know, hexagonal architecture, all of that. If I have a dependency on a storage system, it typically stays in its own package or module, but a dependency on a queue tends to percolate through multiple layers. So changing this library is statistically more difficult for me than changing a storage library. How can I solve this problem? Good question. With an open source software. The software is called Dapper. We'll see in a moment how it works. It's a service, it's a project that was released in 2019. It's a project backed by Microsoft, CNCF backed. It's a portable event runtime that makes it easy for developers to address common concerns, to build resilient systems and applications that run on the cloud, on edge, on premises, in a variety of different frameworks in a standardized way. Let's see how Dapper works. Dapper works using the Kubernetes sidecar container pattern. So you deploy a sidecar container, and rather than, from your app, rather than going directly to the dependency, you go to the sidecar container that then goes to the dependency, and you don't know what the dependency is. In our case, we had a microservice talking via SNS to another microservice. If we inject Dapper, the sidecar container, the microservice talks with Dapper, and then Dapper behind the scenes talks with SNS. Then from Dapper, I can swap SNS with PubSub. The application knows nothing about it, and I can deal with it. So Dapper allows me to significantly increase this portability. So now migrating really is, on the left side, simply changing the application to call an HTTP endpoint, and on the right side, changing now the config. So now we can, using Dapper, change the configuration and tell Dapper, don't use SNS because we're not on AWS anymore. Use PubSub on GCP. Way easier. And another common trend that we're seeing. And the second common trend, the second takeaway of the talk is when thinking about portability of applications from one place to the other, the trend in the industry is to shift from source code concerns to configuration concerns. And you as a platform team, as a DevOps team in a company, can build solutions for your developers that don't need to be platform aware. They can build whatever they want. The trend is move to the configuration rather than staying with the source code. So Dapper offers a variety of services. We looked at queuing, so it can sit in front of a queue, but it also offers secrets, offers observability, offers a service mesh, service-to-service communication, locks, and a number of other features. The idea is very, very powerful with Dapper. And as I said, you can talk with Dapper via HTTP. But one thing I want you to think of is that Dapper is not perfect today. There are problems. There are some problems that are inherent in the logic in which Dapper operates. If you have a very complex Java monolith, maybe backed by Tomcat, who knows? If you have a complex Java monolith that does something clever, like listening to one queue and then at runtime dynamically sending a message to a different queue, well, with Dapper, you lose that, because now it's Dapper managing the queuing, so you know nothing about it, so you cannot be that clever, which is a category of problems that Dapper has. Fair enough. The second category of problem, which I think is more interesting, we can see it with secrets management, another feature of Dapper. So in our initial application, we were using HashiCorp Vault deployed on AWS. Now we're moving to GCP and we're using Secrets Manager on GCP. Very, very close, not a one-to-one replacement, but very, very close. We want them to store secrets. How does it work? Well, our microservice was talking with Dapper to Vault. We can swap. Say, okay, microservice from Dapper to Vault talks with Secrets Manager on GCP. But there is a subtle problem here. The subtle problem is this secrets format. So this is called multi-key value pair per secret. So HashiCorp Vault lets you store multiple key value pairs per single secret. Secrets Manager doesn't do that. Yeah, but what does Dapper do in this case? Because this is the subtle thing with Dapper. The subtle thing with Dapper is that if you have to mediate across 5 different services, you have to go down to the lowest common denominator. You can use any advanced features, because if you use the advanced feature, then you lose somebody in between. You cannot move around as easily. So in our case, that was perfect. We had a very, very straightforward, simple case where we were making a cursory use of the application. Perfect for Dapper. If we were to do anything more complex or more clever about it, that would not have helped us. But here we are, it's a solution. Okay, let's continue our migration journey. Finally, we did with so many things, we dealt with so many things. We try to, are our microservices up? Yes, they're up. Our users, are they uploading images? Yes, they are. everything is up and running finally, and we're using all these clever technologies to keep us happy and happy. And then, why is our SRE team screaming at us? Why they come us with a baseball bat and they're saying, you crazy people? Why are they saying that? Any ideas? Access to GCP, close but not there yet. Sounds like you need some help here. So here is a hint. There's Terraform on a trash can. What has happened?
You have to replace all of their
Yeah, so I have to replace all the code in Terraform. And our SRE team was screaming at us because we are migration people, don't forget that. We're Cube people. We don't care about Terraform. So what do we do? We just use the console. Oh, but that's heresy. That's unacceptable. But the problem stands. If I am on AWS, I have a Terraform resource called S3 bucket. If I go on GCP, I have a different Terraform resource. All that source code needs to be written, not very portable. What can I do? I can use another CNCF project called Crossplane. Crossplane is a very clever project that lets you use Kubernetes YAML to declare resources external to the cluster. It's a control plane framework that really keeps things in check. So it's so complex in explaining, but super simple to understand. You deploy Crossplane in your cluster, then you create a YAML file that you deploy kube control apply as all the other resources inside the cluster. Crossplane watches for the custom resource, picks up the new custom resource, and says, amazing, do you need an S3 bucket perhaps? S3.aws? Yes, okay, I'm going to create an S3 bucket for you. So now you can keep the code that describes things inside the cluster and the app, and the code that describes infrastructure outside the cluster, all together in the same GitHub repo. Pretty cool. That gives us a nice place to be. But still a problem stands, which is I don't need to change Terraform anymore, but I need to change the YAML from s3.aws to gcp.cloud storage. Crossplane as composite resources. It's a little layer of complexity. Rather than saying, give me an S3 bucket, I say, give me a bucket. And then our infra team, our platform team behind the scenes can configure Crossplane to read S3 bucket, read bucket as S3. We can look at an example with a Postgres interface. There, I can, as a developer, I can demand a Postgres database, and then Crossplane knows that because I'm on AWS, that Postgres database becomes an RDS instance. And here is the address of the RDS instance, here is username and password. That is a very powerful thing because it allows you to simplify composite resources. As a company, as a team, you can deploy in the cluster resources, using Kubernetes, resources external to the cluster without having to worry about that. So you can increase your portability because you're not relying on Terraform anymore and you don't have to rewrite all that source code. Perfect. Our migration journey. So we did a whole range of things. We stopped a number of things. We changed the source code. Will it work now? Will it work now? Everything is up? Yes or no? Come on, some positivity, guys. All right. Yes, it's working. It's working. Thank you. It's working. One of the concerns is commonly about monitoring. But don't forget this. We are much, much more clever this time when it comes down to monitoring. There are different options. There are a plethora of different services on each cloud provider on how to monitor your applications. You can use CloudWatch, or you can use Prometheus and Grafana. Because we're using Prometheus and Grafana on AWS, we can do the same thing on GCP, and porting dashboards, porting alerts is way easier than using a service that enables us to be more locked in. Something to think about, one and the other. So if you're thinking about AWS, is there a corresponding service on GCP? In the end, what are the takeaways of this talk, the last 2 minutes? Number one, Kubernetes is not feature complete as a platform. I have to go outside Kubernetes when I deploy my applications. When I go out, I have a plethora of tools I can choose from. I have a million things just for monitoring. And so we have this ecosystem fragmentation that brings us to, because you cannot just move one container, you have to move an application that has a plethora of dependencies. Cloud portability is actually hard work. So the hype, I move one thing from the other, not true. Can I move one container from AWS to GCP in an easy way? Yes. Can I move an application from AWS to GCP? Not as easily. With 5 takeaways I hope you remember for this talk. Number 1, ecosystem, super important, plays a major role. Number 2, do you want to increase portability? Consider to shift concerns from code to configuration, where the ecosystem is going. Number 3, use these CNCF open source tools that we saw today that can help porting the application. And in the end, consider that everything for me boils down to a clear trade-off between cost and velocity. And you're not making a technical trade-off when choosing RDS over Postgres or whatever. You're making a technical trade-off. Thank you, guys.